Y'all hear me? And okay, Joe Rogan uploads at the same time. Holy, let's go. All right, guys, let's go. Let's see, 29,000 times of thermite says my first stream that I'm actually here at the beginning, and after like 4 to 5 months. Okay, let's do this. Yeah, for sure. And I just realized you and Joe Rogan upload at the same time. I didn't realize it. Okay, Joe Rogan uploads now. Okay, can y'all hear me? Hear me. All right, we are live, guys. Can y'all hear me? And then I'll post in the other areas. Let's see what happens. I'll check my audio here quickly. I'll lower this thingy a tiny bit. Okay. Okay, it should be fine. Okay, I think it's fine. Everything's fine. And I have Odyssey's opened, and check the other chats, and we'll get in there. We'll try to power through the weekend here. Let's move this 1 second. Okay, I'm gonna just go quickly something over here and move some stuff. 1 second. Edit. How do I remove a chat excluded? Okay. Okay, so we are done. We're back in here. I forgot to do the in Leo audio tip top. Okay, audio's tip top. You mean tipping top? Are you talking about the tower 2? Okay, I'm gonna switch accounts. So again, Hive is just like next level. I'm gonna go switch over here to my other thingy here. But I forgot to set this one up. That's my face in here. I'll quickly set this up. I'm gonna copy this and go right here. And I'm gonna do a threadcast. Just so I can post everything on the Hive blockchain as well. I'll put the images up here. Where's the images go? Gauss's laws. All right, and also 29,000 tons. Yeah, Tell, thanks for the trailers. Yeah, you had the epic trailers there. It's one of the best trailers. Okay, this is. Oh, I thought I was subscribed. What is going on here? This is just ridiculous. I need to pay the Okay, so I've no idea what's. 1 second. Hold up, guys. Hold your horses. Copy. Just upload the image. Can't do everything is just on a Mac is just so weird. Nothing like you like uniformly works everywhere. Okay, this works. And then this one why am I talking? Oh, I'm live on here. Okay, so this one doesn't have a chat opened. This might have a chat open, pop-out chat. Stupidest thing is you have to pop-out chat after the stream is done. Okay, so I'm gonna close these done. And this still doesn't have this. I'm gonna close some stuff. Yeah, I just because I forgot to do the Okay, so there's a threadcast. I'm gonna do a Hive premium thingy right here. I'm gonna pay $10 right now to the thing. I thought it was premium. All right, man, what is going on with in Leo? Okay, I'm gonna just subscribe right now. Keychain, pay dollars. Okay, proceed to payment. Leo pool. Okay, I just paid $10 per month. Okay, none of the originals in the show. Let's go. All right, I'm gonna just go over here now. All right, so we're gonna cover Gauss laws and some random other stuff there, and see what this thingy is. Alrighty. 1 second. I just paid $10 for this thing. All right. YouTube. All right, so anyways, so there's Threadcast. I'll start posting on there and so on. And let's see what the notes were. It's Canada right now, so it's I'm gonna check the score. DR Congo. DR Congo versus England. England is losing right now in the World Cup against Dr. Congo. Check the score. Live updates. Just go to live score. Yeah, so it's Dr. Congo is beating England right now, 1-0. Like, what in the world is going on here? It's halftime, and so that'll be get to watch that. I'm gonna go over to here. Okay, I'm gonna open up some. I'm gonna quickly open up some stuff here, and then I'm gonna go over Gauss's laws and so on again. I thought I had. Okay, I have no notes in here. I think I put it in the different area. It might have been in this Gauss's laws mock discs maybe. Where did I put it? All right. Anyways, I had some questions earlier. I'm gonna go to my YouTube. Someone had a question. We'll keep the score update on here. The 6th channel. Holy. Yeah, that's wild. Yeah, you guys see the upload I just did. This one here. Judy Woods. Where towers go 2011. I'll be posting a lot of stuff I posted on Telegram. I'm just gonna post it like directly live. The World Cup went DEI. Yeah, so the World Cup. Yeah, I'm gonna just check the score updates. Maybe I'll just keep this live like that. Okay, so we're gonna have a tracker there because if Dr. Congo wins while we're going live. Okay, somebody asked a question here about magnetism. Okay, well, actually, Floyd Reynolds says, my question is this is the one that laser-induced plasma to create 3D volumetric images with sound. That's actually quite ridiculous. Yeah, you watch that video, definitely watch that, and then it deals with the 29,000 tons audio lasers that apparently some Iranian official was telling. All right, so Floyd Reynolds says, my question is it just what the public gets to see now? You will know they are done with technology when they introduce it to public. Yeah, but also the video I shared here, this video, it's not actually shared. It's actually older. So if you look at the this is the noise so that's actually laser focused on one spot, and then the sound's coming from the ionization of the air. So it's literally super loud. All right, look at that. But this is like from 2014, I think. Let me open up my I should put the sources directly in the channel. Okay. Oh, yeah, video 3. All right, I'm gonna go over here. Anyways, it's Canada Day right now. So this is 2017. So this video is from 2017, and then the other video, the middle one, is from. I should put it directly. Yeah. This one is from 9 years ago, also 2016. So these are literally 9 years ago, and and the thing is, I'm posting it now, and people are like, "Oh wow, they're telling us now." Except the other video I think is from this year. Okay, so 20,000 tons says every time I go live, Joe Rogan uploads podcast exactly the same time. Did he do that because I'm going live? Like, I think he's trying to get people off the MES math Q&A live streams. Yeah, because this Q&A I go ham in technical science mumbo jumbos, and I figured out how to safely operate my Tesla coil. I'll be connecting it directly to the ground wire in my house, so I'll be doing that. Hopefully next week I could start those. But anyways, I'm gonna go right here, Dr. Congo. And actually, okay, so we have this is the notes there. This is Dr. Congo. I'm gonna continue. Oh yeah, this laser-induced plasma. I'll just take a photo of this setup here. Yeah, and the other thing, if you listen carefully, what he says here, like you can have these filaments, so you ionize the air. And then you could pulse like huge amounts of actual current, electricity through it. So you can actually direct power to somewhere, or the reverse, take it out. And again, it was relating to the. So what they would do before, they'd have rockets launch with wires to the clouds to guide lightning strikes. So look at this right here. Okay, so these are So what he's doing is literally they're ionizing air, and then basically allows the lightning to go straight through it. Give it a listen. Okay, so now you can use a straight laser there, and you can guide where lightning comes in. So lightning's coming straight to this laser. Okay, this is mid-2000. I need to see this video. Anybody know where this video is coming from? I'm gonna take a screenshot of this. Oh, wait 1 second. I need to make it I'll open up this thing. So we need to find this exact video ASAP. This is from like mid 2000s, and apparently they're using let's go right here. Military electro laser. Yeah, we got to find that setup there. Okay, I'm gonna see if there's an image. Okay, I'm gonna go. I'll go to TinEye, or Google. Go to Google. Click on this thingy. Check it. Guys, replied to me under your video. Okay. We'll go to the audio laser. They're called phasers. Yeah, I know. Yeah, that's the audio laser itself. Yeah, you just focus sound. Yeah, but stimulate emission of radiation. Phaser. Sound application. Oh, that's an interesting thing. Let's go to phaser. No, is that what you said? I don't think. No, I think it's just sound, focus sound or something. I'm gonna just do Google searchy on this thingy. Okay, sound amplification by stimulated emission of radiation. Phaser refers to a device that emits acoustic radiation. Focus sound waves in a way that can serve as accurate and high speed carriers information in many kinds of applications similar to laser. Yeah, it's basically just focusing sound into like a laser. It's just basically focusing sound. So that's it's just sound. That's just directed. Like if you have a funnel, you know, you can funnel objects inside. Yeah, but you can do that with sound and so on. Okay, let's check the. Okay, England. Okay, just missed. All right. Yeah, so this is the video I want to see. This image depicts a U.S. Army test of a lightning gun called a laser-induced plasma channel. Okay, so Fox News has this one. Okay, is there a video on this? Army looks to strike foes with lightning weapon. It's 2015, published 2012. A guided lightning bolt travels horizontally, then hits a car when it finds the lower resistance path to ground in a U.S. Army test. So a guided lightning bolt. How are they guiding? Okay, so they're so this, I think it's like on a bridge or something. Okay, so a guided lightning bolt travels horizontally. So they got the lightning bolt to go horizontally. Create an energized plasma channel in the air, an invisible pathway for electricity to follow. The laser-guided lightning weapon could precisely hit targets such as an enemy tank or unexploded roadside bombs, because such targets represent better conductors for electricity than the ground. All right, this is I need to see a video. Is there a video on this? I'm just gonna archive this thingy. Okay, I'm gonna archive this in the. I thought the guy told me about audio lasers meant ultrasound, but no, ultrasound is just the frequency. It's you can focus ultrasound. You can focus different types of frequencies of sound. I'm gonna go Army looks to strike foes. I'm gonna just publish this one here. Okay, and then that's pretty wild there. But is there a video or anything? There's no video, just images. Is it just an image? Like that's how big, that's how important it is. They don't even show it a video. They just have an image. It's all the government was willing to give for the guys to write articles is just an image. Like what in the world is going on here? I'm gonna go and put this. Oh, whoops! Put it back. Yeah, I'll put it like this. All right. So this is gonna be there. I'm gonna put this in here and ask Leo summarize this article. And I should be a premium now because it's premium. I should have it now. Okay, summarize the article. Let's see what happens. Live update. Let's go back here. Okay, so I just like archiving everything. So that is, and this is just basically just sound amplification. Okay, and then this other says, yeah, that's audio laser. Yeah, you were discussing audio laser, but this is a different thing. Like, plasma itself generates sound. Because it ionizes the air. The air gets ionized. Like so, the sound is an after effect. Yeah, low quality image as well. So like, think about that. The U.S. military is like, okay, we'll tell you this, but then everybody writes it as if it's 100% true. It's like, okay, there's an image, yeah, but you have to trust them. But you're gonna show a video or anything? Are they sending propaganda and so on? But again, obviously, yeah, obviously this is true, but it's just a photo. Like, what are they doing? Why are newspapers just writing it just for clicks and all that? Again, that's how pretty much mainstream news is. Okay. Okay, so here's the full thread cast on that. It's pretty cool. So the army was testing a weapon concept that sounds like science fiction, using a laser to create a path in the air, then send electricity down it like a guided lightning bolt. Okay, so lightning bolt is just sending electricity straight to it. So again, you can literally power things. You can guide electricity without wires. So you ionize the air, that becomes like a current. I mean that becomes a carrier for electricity. All right, so we got that, and yeah, that's pretty cool. But again, this is I got an AI bot live on the blockchain, like, but I do pay for premium now, so that's because they upvote and so on. So you actually make more than. So the cool thing is I pay the $10 a month, but the upvotes by the guys who make this, it pays more than $10. So like yeah, every month I'll just pay, and so on. All right. Anyways, go on here. Okay, so I'm gonna go. There's another question here that I didn't get a chance to. Okay, this person, because someone's using my videos. I don't know who's there. Thanks for sharing. Okay, somebody said here. Okay, where's the? Somebody was talking about the other video. I'm gonna go to the video. I'll go to my videos here. Okay, yeah, I forgot to share that link. Okay, we should share that other link's pretty straightforward. Okay, this is the one I want to go over. No, not this one. The experiment I did on the where's the experiment? Holy, where's all these comments coming from? It was the one about this one here. This guy was asking. Oh, my mic's a bit loud. Okay, yeah, you are right. I'm lowering it now. How's my mic now? Yeah, it is good. Before they always had the issue of the mic was too low. How's it now? Okay, how's it now? Okay, I made it less than the red thingy. Okay, let's check it out. Yeah, because I did notice it was loud before. Too low? I don't understand what's going on. I'm gonna just do input volume. Okay, how about now? Too low? Too loud? Too low or loud? I think are you wear headphones? Like I don't know. I'm like blasting it here. Like I don't know what's going on. It's loud for me. Oh, 10% lower should be fine. Okay. But why are you saying too low? Yeah, but you said too low and then too loud. What is going on here? Okay, I'm gonna do this actually. Okay. So, anyways, let me know each time. Okay, better. Is it better now? So again, there's a slight lag, so you'll have to tell me. I'm gonna go like this. I'm gonna go like this, and then lower this. Okay. Actually, this might be better. Yeah, I'll just do this. Okay. Anyways, so let me know if it's good or not. So, let me know now. Okay. So, anyways, we'll continue on further. Yes, this person was asking right here. This was the magnets glued together and repulsion falls slower in a copper tube. I'm not sure if you guys seen this video. This is I made this giant one. And then I have a sped up one here. I'll just do the Gauss readings. So here is the experiment. So yeah, when you drop a magnets and repulsion, they drop super slowly. Okay. Okay, so this is north, south together, and he super glues them. This is they become super strong. It's ridiculous. Okay. Okay. So look how slow it goes through the copper tube. Look, it's so cool there. I'm gonna check the results there. Okay. Okay, so that's this guy says okay, so for those who are sort of magnet dummies as it were, what is causing the magnet to resist the force of gravity here? It isn't air pressure because the tube is open on both sides. What's going to use a copper? Um, the copper pipe is the entire section, not just the end. Was it experiment you already killed yourself doing? Oh, it's the one yeah, it was pretty dangerous. Like blew up and so on. I was doing that. I still have them glued together. It's pretty fascinating. And just in case I have another idea for an experiment. Yeah, the cover. This is the one that what's his name? Oh yeah, Paul Mueller made these ones for me. So I told him to do that. Okay, 6 feet 4 above. Interesting. 6 feet 4 above. All right. Okay, I got a basketball player right here. Okay, the cover pipe is the entire section, not just the end. The earlier, yeah, the higher section just has magnetic viewing film around it. The mainstream narrative narrative is that eddy currents. Let's see what this is. Eddy currents wiki. So eddy currents, apparently it's just like moving magnetic field and then generates eddy current. Is a loop of electric current induced within conductors by a changing magnetic field in the conductor according to Faraday's law of induction. I'll send a link here. Is that that eddy currents form when magnetic field changes along a conductor, which itself generates a magnetic field in opposition to the generating the initial something like that. Yeah. But this is surprisingly way more pronounced with magnets and repulsion. So here's a wiki there, and you can go read up eddy currents on. So that's the mainstream narrative on that, and I will okay, I'll just take a I'll take a screenshot of this one actually. I'll zoom in and then zoom out. Okay, how do I just take a screenshot? Okay, this is gonna be like that. And then we'll continue on our, whoops, this should be here. Okay, and then here. Alrighty. Okay, so that's it. And zoom back out. 1, 2. Why does the other one zoom in? This should not zoom out. It should be, whoops, 1. Okay, anyways, let's continue on. Again, if you guys have math, science related questions, let me know. Let me know if any of y'all have math science questions. Otherwise, I will be wilded. Yeah, so anyways, guys, so basically, you know the drill. You ask me questions, otherwise I'm just gonna do my thing and learn as we go. But also, I think Chris Berger was messaging me on this something here. Oh, what in the world just happened here? What in the world is going on with this guy's face? Who's the guy? Somebody sent me a text message? Where'd like Chris Berger send me a message or something? Anyways, I don't know what's going on. Okay, so let's continue on our journey. I'm gonna send this a threadcast into here, and yeah, another thing I was gonna yeah, this the filament stuff. Okay, so we went over that, the electric filament setup there. Oh, but also another thing I wanted to show quickly, so I didn't need to post this because this in this video. Let's see if I can find some good ones. So next Saturday, not this Saturday, next Saturday, the doctor will be in town. She'll be, I mean, not in town, in the stream. We'll go over weather anomalies. I mean, like, listen to the part she talks about the hurricane. So she can do anomalies on hurricanes and tornadoes and other stuff like that. So I'm going to go into the hurricane part right here. So this is, where was the time section? Okay, if I go to here... If I go to the this part right here. So listen what she says about the hurricane. But also this one, this tornado forms from the ground up, not the top down. Let's play right here. Also, I forgot the desktop. Okay, guys, I had audio off. Let me know the audio. And guys, let me know if I play something and there's no audio. Okay, I absolutely hate every time I have to do something. Okay, this is gonna be audio. And because of this, I made a mistake before because you guys weren't hearing this. This is the one that has super loud sound. Why can't I just open the thing? Like, I don't get it. What is up with Max? Like, just open a link. Is it that hard to open a link? Okay, so I need to do, I need to go here. And I need to click a direct link. This one here. Okay. So look at the sound. Now I have the sound on because I had it muted by accident on my other end. Yeah, look how loud the sound is. This is double speed. That's wild. Okay, so that's sound there. And now look at this hurricane tornado.
Look at that!
It's forming from the ground up.
Oh my god! Oh my god! Look at the funnel! This is incredible! We're backing up. We are. Oh, I hope he backs up. He's going to be right in the middle of that. Oh my god! Are you getting this meeting? I'm getting it. I gotta get some shots. I gotta get some stuff. Hang on. Ow! Sorry.
Oh, okay. Timothy, someone's in the house. Okay, let's go, Tim. Okay, yeah, Facebook's still a thing. Yeah, Facebook is. Yeah, I just have it because yeah, some people are on it, and so on. And I also upload my some the videos and so on there, the MES ones. But Facebook is pretty ridiculous. But yeah, anyways, Timothy Solon. Hopefully you enjoyed our conversation about the MH370. What is this called? Yeah, the plasmoid guy. We'll call him the plasmoid guy. Anyways, pretty wild.
Look at this baby. Look at this.
So this tornado again from the ground up formed. Yeah, and listen what she says. And apparently, like, she heard witness testimony that people that were inside, like that are levitated inside the tornadoes, like thrown around, they didn't have trouble breathing. Listen what she says.
Folks think of tornadoes as being like a vortex, that, like a toilet draining that comes down from the sky. It's an energy field, a vortex type of energy field that happens to occur naturally. This one started from the ground up. It's a potential between the clouds and the ground. It turns out that there's a whole lot of similarities between this and what happened in 9/11. People talk about anti-gravity. And those who've been inside a tornado and picked up by one, they can breathe fine. It's not like a big vacuum cleaner.
Okay, notice that it said they can breathe fine. So they're flying around inside the tornado, yet their air is like they're as if nothing happened. And wild and sounds just like just a thing today. Yeah, definitely. Yeah, there's a lot of wild in there. So basically, here's my pro tip. Anybody that says anything, doesn't matter if it's like 5 hours long, 10 hours long. The first verifiable claim you find, go and try to verify it. If you can't, you can easily assume that they'll be wrong about most other things. All right. So anyways, that's pretty well. So and also notice here what I did. I replaced the and then all of a sudden stopped replying to DJW and Andrew Johnson, and then now it's pretty much like it's like a skeleton of itself, but it's leads open now. Before it was like shut down, but the person will not give up control of this. So don't go this. Go to doctor with just a full spelling, and so on. Yeah, so just get there. And yeah, so here's the real one, official, authorized official site. So the other one's not authorized, and so on. She talked about the first runners on saying that the fires wouldn't go out by pouring water on. Yeah, there's a lot of stuff like that. And if you see the video I uploaded on my MES Truths one, the reporter, or I mean the camera guy, the photographer, thinks that the water made the fires worse. Do you hear what I just said? The guy thinks the water made the fires worse. Okay, listen. This is the MES Truth here. Yeah. So if I go right here, MES Truth. This guy here, Pentagon photographer Bob Pugh or something. Let's see how it spells. See how do you
My name is Bob Pugh.
Bob Pugh. Okay, Pugh. So if you go to water right here, and again, this video I made because I'm working on a dust video. Dust video is gonna be absolutely mind-boggling. If I go to what is it called? Water. Yeah. So here.
Of the fuel. What I was seeing immediately was they were pouring water into the actual firefighting itself, which I believe probably spread the fire deeper into the building.
Okay, listen to what the guy just said. This guy just said they were spraying water into the fire, and he thinks it made the fire deeper into the building. Well, what does that mean? Oh, how do you throw water in there? What do firefighters do?
Probably spread the fire deeper into the building.
So in other words, it's an electrical fire. It's not a normal fire. Listen to this guy.
Probably spread the fire. I believe probably spread the which I believe probably spread into the actual seeing immediate plane. I'm sure they came because of the fuel. What I was seeing immediately was they were pouring water into the actual firefighting itself, which I believe probably spread the fire deeper into the building.
Yeah.
Just carried it further and further along. I don't know that for sure, but it sounds logical to me. There was
He says that it sounds logical to me. He said there's no foam, there's
no foam, and there was no actual fuel fighting going on at that time.
Fuel, but they're throwing water. What does that mean? Okay, so I'm gonna go back here. John's board experiments in water too. But again, there's he has that stuff happening in a lot of different areas. I'm gonna go right here. No, go back here. Oops. Go back. Okay, this one here. Yeah, look at this testimony there. I'm gonna put that in there. Oh, and yeah. So again, I think it was a great idea that I made the two channels. It just helps. Like I can literally post without feeling I'm getting too out of the place. So again, so subscribe to both channels. You'll see this one will be more conspiracy side and like short clips, and then the MES one will be more full on. This thing he said only makes sense on 9/11. Yeah, definitely. Again, he's throwing water in. Water makes fire grow. What's this guy talking about? Like, does anybody listen to themselves talk? Yeah, it's just like nobody has a. It's like people not stop and think. Like, is anybody just like, yeah, it's just mind blogging. I'm gonna click here. Okay, so there's the video there, and then the other part in this one here. If you go to the boots section here, so it's like nobody's stopping and thinking. Like, what are you guys talking about? Like boots. This lady here.
Steel-toed boots is one of the biggest things.
Steel-toed boots?
Steel-toed boots. Out, still on the rubble, it's still, I believe, 1,100 degrees. The guy's boots just melt within a few hours, and they're burning their feet.
Okay, so it's saying
The guy
1,100 feet. Their boots are melting and they're burning their feet, but their feet. Well, no, there was she said there's no reports of burned feet. But also, if your steel boots are melting, all right, you would be dead. That's like everybody around there would be dead. So yeah, something's wild in there.
guy's boots melt in a few hours. We have no reports of burned feet. Yet this statement was repeated over and over again. I don't blame these gals at all. They're trying to explain something. Boots are apparently disintegrating, and they need to be replaced for some reason. But if it was 1,100 degrees and these guys are walking around in boots that are melting, we should at least have a few reports of burned feet.
Yeah, but also again, if your foot is melting, I mean, if your shoe is melting, your body would be like dead. All right. So if your foot is melting, your entire leg and body it will be vaporized. All right. So that's wild and stuff. Yeah. This is, I'm gonna go right here. Boots melting. So we have it in there. Steel toe boots melting. And then put the transcript here. Like, yeah, nobody's just listening. And why is this guy get like recommended everywhere? Unbelievable. Okay, let's go back here. All right, the doctor. And how do I just pause right here? All right. Steel toe. Oh, England just scored. Okay, no, steel toed boots melting. England just scored against Dr. Congo, and that Harry Kane guy scored. Yeah. So imagine that you're fighting terrorists or something for hours, and that's happening. It's like that's not happening, guys. Why? Where's the thingy there? Okay, there's the book there. All right, that's wild stuff. Yeah, so guys, anyways, guys, definitely subscribe to MES Truth, and you'll see other stuff like this. If I go to the MES Truth one again, so if I go here, so listen to the Ron Johnson guy. This is the senator guy. Apparently, all these disinfo spooks are trying to like get him to talk about 9/11 or something. He's literally standing next to this Richard Gage guy. Oh, yeah, I'll go over some more Richard Gage stuff before I get into the Gauss law. But listen to this guy. He literally says. Government won't release full truth of 9/11, and he's standing next to absolute clown show Richard Gage, and but when I uploaded the video, it accidentally made it like I didn't do this on purpose, but it's 119 length. The length is 9/11 backwards. That's pretty wild. Let's play it here.
One of the
Notice how for 5 seconds he's trying to think about how he's gonna phrase this to not sound like a complete and utter spook, which he obviously is.
That I think it may be difficult to get to the very truth is if you really think about, well, what are the theories? You know, what could have, if it wasn't Al Qaeda solely.
You notice how he's laughing there. It's solely.
If there were people that helped him, okay? If that were known, what does that do to our world? I mean, we all, I think we're all old enough here. We all saw 9/11. We all remember that moment. You probably uttered the exact same thing that about 2 billion people uttered that day is this changes everything. The full truth may do that as well. So again, I don't know whether the full truth can ever be possibly revealed. I'm not saying I would do anything to cover it up.
And notice how he why would he have to say that? What's the point of saying it? You don't need to say like he wouldn't do it. In other words, this is like a statement analysis, like in police investigations. This is a tell that he doesn't want it. He wants it covered up. Let's see how he phrases this.
Possibly revealed. I'm not saying I would do anything to cover it up.
So the phrasing is, I would do anything to cover it up. Okay, but he clarifies with, I'm not saying. But he literally just said it.
But I am saying I would understand, based on some of the theories, why even responsible government officials might say, I'm not sure this is something we should release. I'm just giving you the resistance. I'm trying to make sure you understand what the reality situation is here. Okay.
Yeah, definitely. Yeah, so he knows about. Yeah, I think conspiracy realists sent him a bunch of packages. But again, Johnson knows he's obviously a Freemason. I'm gonna put this here. Another thing I'm gonna do quickly. I'm gonna go right here. Yeah. So one video I have. I'll be working on. It's gonna be one of the funniest videos probably ever. If we go to Richard Gage, 9/11 was a. Where's the okay? This guy here. Okay, so.
In a matter of weeks.
Okay, so I'll be. So I downloaded this whole video. It's like almost 3 hours. I'll be going over. all the times he stutters and says or just says nonsense, and put it all in one compilation of highlights or lowlights. It's pretty funny. But also one thing I wanted to see here, if anyone can find info about his past here, is I don't know I don't know if this is real, but look at what he says.
I saw those towers coming down.
And the way he talks is so like bizarre.
Know what I was seeing.
I'm gonna go back to the pole vault. Okay, so apparently he is a professional wrestler. Wrestling. Okay, so let's listen to here. Listen what he says here. Is this guy realistic? If somebody can find info on this, Attila, divergence, if you could find anything on this guy right here, on his
right. I grew up in the San Francisco Bay Area. As a teenager in high school, I was a sports enthusiast. I did football. I did wrestling. I was a pretty good wrestler, actually. Won the North Coast title. Yay.
Okay, he looks like a robot when he says this. Look at how he talks.
Won the North Coast title. Yay. Pole vaulting and high jump. I actually did a lot of those things in track, and went to school, college at Sonoma State University, and studied psychology.
Okay, so that's interesting. Studied psychology again. He's a psyop guy, but also he did pole vault. He was a North Coast like title for wrestling, and he did high jump. So he's doing. It looks like he's an athlete. Okay, there he is. There, look at this guy right here. Okay. Okay, I'm gonna. We're doing, guys. You guys are seeing MES live, creating a thumbnail. Okay. So and also notice the AG. Just I don't know. Somehow looks like Freemason logo. I'm gonna go to Grok right here. I'm gonna go and let's go to an image. Make him turn into a clownish Hulk. No, a good wrestler. Well, he was in high school. He was, but no, wrestler. You're not punching people's ears. No, a wrestler. You don't. Fighting. I'm not sure if he'll have cauliflower ears that much, but the guy is. He is doing professional wrestling. Make him turn into a clownish Hulk. We'll do an image. Okay, and then we'll do a video, and then we'll get into the gaps of law and so on. But again, it's Canada Day right now. I can do whatever I want. Wrestling is wrestling. Wrestling. Have you seen that South Park episode? It's like, oh man, he has wrestling on his phone. They had to like suspend the principal or something because he had inappropriate material. He had wrestling on it. So there he is. Okay, I'm doing expert mode to make sure it's effective, and I'll do a new chat. I'll do a new imagine. Okay, here. Make him rip his shirt and turn into a clownish Hulk. Okay, let's see how this goes here. Let's see how this will look like. It's generated. We're doing some AI, guys. We're doing deep AI research. It's like we're using the most advanced intelligence, the intelligence tool of like ever, like AI, just to make this guy turn into a clown. Clownish Hulk. Let's see this. Oh yeah, legit wrestler. Yeah, but it was high school. Yeah, and I understand, but again, he's he could have a different yeah. Is Richard an actual architect or paper push? Okay, there he is. Okay, he's ripped it up. But I want to keep the resemblance though. Okay, that's good enough. Okay, this is make him turnish, but keep the general resemblance, especially his face. Okay, so his face is the most important one.
You can't handle the explosive truth. I'll rip this lie wide open. Feel the Hulk's wrath. You can't handle the explosive.
Okay, no, but yeah, clownish Hulk. Make him more clownish. Okay, and now there's limits. I only can do like 3 a day, so this is gonna be like, okay, last one. I just guess this one and later I'll do. Okay, I'm gonna see. Okay, keep the resemblance though. Okay, let's see what he says. Okay, anyways, we should get back into. I'm gonna just open up Gauss. Okay, let's see what he says. That's ready.
Show you the truth. Rag! I'm the clownish Hulk of truth. Ah! The evidence is explosive. I'll show you the truth. Rag! I'm the clownish Hulk of truth. Ah! The evidence is.
All right, okay, we did it. We did it. We've done. Just save video as. Okay, okay. Okay, guys, I'll upload this soon. I'll just share this. Let's see here. Okay, that's good enough. Okay. I'll post it on MES Truth later. But anyways, so we have done our or open up this up like that. Okay. I'll just put this right here. I'll save this one here. Save video as, and then I have a gauge set up there. I have like a whole Richard Gage Clown Hulk. Okay, let's just open this up. Where does it go? Why does it do that? And then just open the folder. My goodness. Where did it go? Okay, and I'll just post this right here, and we're good to go.
The evidence is explosive. I'll show you.
Why isn't it? Why did it go there? Here. All right. Okay, so there it is, and that is that. I'll paste this thing in here, and that was the image, and yeah. All right. So there's the Incredible Hulk. The Incredible Clown Hulk. Okay, I'm gonna start sitting down. Okay, we got alrighty. Anyways, I'm going to okay, so we've done our business. Okay, where's this paper pusher one? Let's see if he's actually a paper pusher.
Richard, I'd like to ask you some questions about before you were actually an architect and when you first decided you wanted to be an architect, and how did that happen, or what was the interest in architecture for you?
It was just a fascinating subject for me. It came later in life. I had 10 years of wandering in the wilderness, if you will, doing various labor and so forth. But then I ended up helping out, running blueprints in an architecture firm. So I said, wow, this looks fascinating. So I took some evening classes and ended up at USC to get a full education and apprenticed with architects in the Los Angeles area, and became an architect. And I've been loving it ever since.
Okay, we've been talking about, or we're going to be talking about, a lot of some technical stuff. And usually architects are often praised for their creativity, but in fact, to be an architect, and you can comment on this, but you have to know something about engineering, about science, about structures, and that sort of thing. Would you agree?
Yeah, we have a lot of engineering classes in architecture. In fact, I was the student teacher for structural engineering for the freshmen that were coming in. And I enjoyed that quite a bit. I like the technical end of architecture rather than those who excel at the design end. I put buildings together, construction documents, and make sure the buildings get built properly with the construction administration services.
Yeah, I know that seems it seems all right. It's what do architects do? That's pretty much what they do. That seems that's an all right thingy. That wasn't a gotcha on Clown Gauge. See if I have email opened. The other thing. Okay, let's go back here. Alrighty, I'm gonna go into here. All right, yeah. So there's the anything goes. There's him clowning. Oh, there's some other clowning set up there. So anyways, I'll be going over that. When Boston was for a casino. Okay, yeah, that's interesting. Interesting. Yeah, send me get some links on that. Another thing is I heard that again, don't quote me. Apparently, before he became a yeah, another thing. Okay, this is another clip I'm gonna
There you
including
go.
in there. If I look what he says here, he's a full-time 9/11 truth. Like, what do you mean by full-time? Full-time. Years. See, where's the years? 9/11 truth. Okay. I want because he does this full-time. Time. Okay, let's see, truth, where's the, oh man, 15 years, I think? Okay. No, wait,
Yeah. It's possible.
no, this is, he literally says he works full-time. Yeah, let's go to the, full-time, beginning. Okay, it's gonna be early. Okay, lengths of gauge and project. Yeah, okay, but that's a grok thing. I want to know what the exact link is. Like, grok is, yeah, okay, the full dash time, okay.
7 years later, 37 years later. I'm now full time, actually, for the last 15, almost 20 years, full time on 9/11 Truth.
So full-time 9/11 truth. Hear what he just says. Full-time for 15 to 20 years. Almost 20 years, full-time 9/11 truth. Yeah, where's the gauge project? Where's the link there? But yeah, credentials. But where's the thingy there? Okay, it says, I'll look at that later. So I'm gonna read. He's a professional idea, but 15 to 20 years, he says, almost 20 years. And England just scored, guys. Unbelievable. Dr. Congo's losing. DR Congo. England. Okay, so England is up 2-1 now. So we are. Okay, so England's winning 2-1 now. Last minute now, unbelievable. Dr. Congo is up 1. Okay, anyways, I'm gonna go into straight up Gauss law for the last hour or so. Yeah, so anything goes podcast. Like, what kind of nonsense? James English. That's like that sounds like that Mr. Bean double agent guy. So again, James English is obviously a fake name. All right, so that is that. So he works full time on 9/11. Okay, gotta run. Yeah, for sure. Okay, I'll be doing a bunch of Gauss law. I'm gonna just take a screenshot of the full time here.
Cool. At USC, University.
I'm gonna go full time here. Like, what in the world does that even mean? Full time. Okay, I've been full time.
7 years later, 37 years later. I'm now full time, actually, for the last 15, almost 20 years.
Holy. This is unbelievable. Unbelievable. Okay, 10 years. Richard Gage, full time on 9/11. Quote truth. Wow. Alright, this is mind-boggling. Alrighty, and this is quite ridiculous. Yeah, full-time salary, and its salary was 120K USD per year, and that was like early on. It's probably higher now, probably 150 or something, with inflation. Okay, and I'm gonna go Gauss's law now. All right, guys. So I'm gonna go over Gauss's law, just because this is last time I went over Maxwell's equations. And what happened here? Okay, Maxwell's equations. So I went over Maxwell's equations. Look at this, asking for money. Like, just get away from me. Unbelievable. Okay, so Maxwell's equations. There's set a couple equations. Don't forget about the donations. Yeah, again, even donations. I think it's a small part. He's getting big money from spooks. Like, that's how you launder money. It's like, there isn't that many people. There's not a chance in the world he's getting 150k USD from actual normal people. He's getting it from people who want to wash money, intelligence agencies, and so on. All right, so I'm going to go over here, Maxwell's equations. Yeah, so again, these were these first ones. So Maxwell's equations, and yeah, so let's do some science. Yeah, so the reason I was going over these ones, so in partial differential equation form and SI units, Maxwell's microscopic equations are written as, and again, these equations are, together with Lorentz force law, they form the foundation of classical electromagnetism. So this is basically, electromagnetism, you want to understand it, you look at Maxwell's equations and Lorentz force law, but then there's different ways of writing it and so on, but that's the general idea. So, and now I'm going to go over, so I'm going to go over each of the equations, but this one in partial differential equation form and in SI units, Maxwell's microscopic equations are written as top to bottom Gauss's law. So this is about Gauss's law for electricity, and then, or electric fields, and then Gauss's law for magnetism is this. And then there's Faraday's law, Ampere's, Maxwell's law. We'll go over those in another video here. And then this is a macroscopic version, but the same idea. This is Maxwell's macroscopic equations are written as, this is going to be, this is the divergence equals to, this is the density of the charge or something. D is electrical displacement field, E the electric field, and the free electric charge density. And this is just macro, but in the microscopic sense is this. So E is the electric field, and then B is the magnetic field, and then rho, that's the Greek or Latin letter rho, the total electric charge density, and then E naught is the vacuum permittivity. All right, so that's a vacuum permittivity. We'll discuss that later. But essentially, this is just how much electric charge is there. And what they're saying here is that the divergence, this is the divergence operator of E is proportional to the charge. And in this divergence, what it just means is how much is going outwards. And this is basically a derivative mumbo jumbos. So divergence of a vector field is equal to the partial derivatives of its components and add them up together. So to give you an example, let's see if I draw this. Yeah, I was going to think about drawing it out, but yeah, it's pretty straightforward. So like if you're accelerating forward, your basically your position is increasing if you're just moving forward. So yeah, so essentially what that means is, yeah, you'll have a positive derivative or positive rate change. So what there's a Dr. Congo last second free kick. Let's see, Dr. Congo last second, 1 second. I'm gonna watch this last second here. Okay, so Dr. Congo right here, last second free kick. Okay, I'll put it like this. I'll watch it through the camera here. Did it score or not? I'll make this bigger. No, it missed horribly. All right, so I was watching through the mirror. All right, yeah, that's pretty much it. That's last second they missed the free kick. All right, anyways, guys. Yeah, so basically the derivative, if it's positive and you add them all up, it just means how much it's expanding in pretty much all directions. And I'll watch some videos on that. So this is going to be, so this is the top one, Gauss law. We'll go over Gauss law first, and then Gauss law for magnetism second. And then this divergence of magnetic field is 0. So this one's very important here. So in electromagnetism, Gauss law, also known as Gauss's flux theorem, or sometimes Gauss's theorem, is one of Maxwell's equations. Who's Dr. Congo? I know a Dr. Gonzo. No, it's the Democratic Republic of Congo. But they call it DR Congo. So I call it Dr. Congo. DR Congo versus England. So I think it's like last second England wins. Yeah, so DR Congo, Dr. Congo. And yeah, they just won last second. All right. Or not last second, but the Harry Kane guy scored some epic goals. All right, so anyways, Gauss law is an application of the divergence theorem, and it relates to the distribution of electric charge to the resulting electric field. Yeah, so Dr. Congo. In vector calculus, the divergence theorem, also known as Gauss theorem or Oester's theorem, is a theorem relating the flux of a vector field through a closed surface to the divergence of the field in the volume enclosed. The flux of a vector field. These, again, a lot of this is just vector calculus. People don't realize it is Gauss's theorem on that. But the surface integral of a vector field over a closed surface, which is called a flux through the surface, equal to the volume integral of. Okay, this is explanations through liquid flow. Yeah, I did describe this. I'm gonna see. This is when I was working on video on this. This is gonna be pretty intense. I do need to wrap my head around it. And that's another part is another tidbit I want to give people. When you see alt science people casually dropping like huge technical terms rapidly, aka the plasmoid toroidal vortex guy, you know he's capping. He's making stuff up because it's not easy. Stuff like this stuff requires a lot of thought to just understand it. So I'm gonna go over to Gauss' law. What is Gauss' law? I'm gonna go. Actually, I think I'm gonna go to the grok setup here first. So Gauss' law is essentially this part right here. This is the Gauss' law may express. Okay, now they're doing integrals, but in the differential form. I like the differential form. Gauss' law can alternatively be written in differential form. So basically, divergence of the electric field, and then E is vacuum permittivity. And this is another thing I need to learn up. And then rho is the total volume charge density, charge per unit volume. Denoted E naught, pronounced epsilon naught or epsilon 0, is the value of the absolute dielectric permittivity of a classic vacuum. It may also be referred to as a permittivity of free space, the electric constant, or the distributed capacitance of the vacuum. It is an ideal baseline physical constant, this right here. It is measurable of how dense of an electric field is permitted to form in response to electric charges and relates the units for electric charge to mechanical quantities such as length and force. Okay, this is I need to like wrap my head around this. The vacuum permittivity, commonly denoted E epsilon naught. Okay. Absolute dielectric permittivity. So you can't. The definition of vacuum permittivity includes permittivity inside the vacuum. Okay. Often simply called permittivity and denoted Greek letter epsilon, is a measure of the electric polarizability of a dielectric material. A material with high permittivity polarizes more in response to applied electric field than a material with low. Store more energy in the material. So basically, it's how much charge can be stored inside vacuum of free space. So in vacuum of free space, how much is the actual charge limit? And then this is the density of charge divided by in there. And this is the charge density. Charge per unit volume. So it's like you pack it in, but then you also have to divide by this permittivity thing, how much of the charge you're actually allowed to have in there, or something like that. And then this is going to be divergence, and so on. To go over here. Okay, somebody is commenting. You can't just take a piece of evidence that fits your theory and ignore the rest of it. Stop believing this. Some of it. The towers from dust. Okay, this guy's like absolute clown show. Another question: what's this equation used for? Yeah, this is to basically see what happens with electricity. Let's see what it's used for. I'm gonna go. We'll ask Rock right here. Again, these when you're designing circuits and so on, you need to grab all this. So, okay, what is Gauss's law? Gauss's law for electricity. Write it in partial differentiable form. And expand the terms and give me applications for its use. All right. So just do expert mode on that while it runs on there. Oh, what is he saying? What is the guy saying? I saw my nonsense. He's replying to the 9/11 alchemy film. Classic cherry, but you can't just take pieces of evidence that fit your theory and ignore the rest of the timeline. Yeah, it's like, what do you want to? It's like I don't care about these trolls. It's like, yeah, it's like some people need to realize you comment clownish things, you're gonna get mocked. like that's what normies should be laughed at. at least sometimes. Like I just like laughing at people when it's so obvious. I'm gonna go to normie 911. So how do you yeah, okay. How to interact with here. So how to interact with people that believe the official 911 fairy tale. Okay, that's how you interact. Alright, this is it's one of the funniest things. Okay. Like, if it's the year 2026, and people are still, or is it 2025 or 26? Yeah, 2026. People are still believing in that nonsense. Okay. So Gauss' law for electricity, one of Maxwell states that the net electric flux through any closed surface is proportional to the total electric charge enclosed. Okay, so this is pretty straightforward. So basically, how much electric field is emitting out of a surface is proportional to how much charge is inside the volume. And basically, it's the integral there, integral form electric field vector there. Okay, and then divided by, this form is powerful for symmetric problem. I like how they made a graph there. Okay, and make it bigger. A closed Gaussian surface, the box encloses a positive charge plus electric field lines point outward in all directions. The net flux positive end equals Q over E naught. Alright, so that's pretty much what his theorem states. So basically, the electric field, if you want to calculate the electric field, is that. And then here's in the partial derivative form, is basically the divergence is this. This is the same thing as writing this integral and that's like how much is proportional out of there. Okay, it's pretty wild stuff there. Okay, and then let's see key applications. Analytical calculation of electric field symmetry cases. Choose a Gaussian surface that matches the symmetry to so E is constant on faces and flux is easy to compute. Spherical symmetry, point charge, uniformly charged sphere, or electric shell, cylindrical one. Yeah, basically you can model stuff from it. So cylindrical symmetry and so on. Electrostatic shielding and Faraday cages. Inside the material of a conductor and electrostatic, this by Gauss law, any Gaussian surface encloses zero net charge. This proves excess charge resides only on the outer surface. So any excess charge is only on the outside. Interesting. Yeah, theoretical consistency combined with the continuity equation guarantees charge conservation. Okay, high voltage plasma experimental context explains charge concentration at charge points, corona discharge, field behavior inside conductors, and shielding in experimental setups. Okay. One of the most elegant and useful equations of physics because it directly links this local source charge density to the field behavior. Yeah, so basically, that's basically what it's saying. It's just saying charge expands outward, and the relationship is to the charge divided by the permittivity of free space. I'm going to go and archive this. So I pretty much generally understand. Let me know if you have any questions about what we just saw there. I'll watch some videos to explain it a bit more. All right. So this is from 10 years ago. Okay, let's see how this 10 years ago happened.
Hi, and welcome. Today I'm going to talk a little about Gauss's law. Okay, so what is Gauss's law? What does it tell us? Well, Gauss's law tells us that in nature there is such thing as positive electric charges and negative electric charges, and that these electric charges can interact with one another without even touching each other through what is known as electric fields. Now, by convention, we say that electric fields are directed away from positive charges and towards negative charges. But it doesn't end there. Gauss's law also helps us to relate the flow of electric field through a given closed surface to the charges enclosed by this surface. Now that's quite a mouthful. What does this actually mean? Well, as an example, let's say you have a hollow cube, and in this cube you place one positive electric charge. Let's also say you have a second cube, the same size as the previous one, and that in this cube you place two positive electric charges. Clearly, the second cube has a greater amount of electric field going through it than the first. We call this flow of electric field flux. So then, let's rephrase Gauss's law. Gauss's law tells us that the net electric flux through a given closed surface equals the charge enclosed by that surface divided by some number that, for now, we'll just call epsilon naught. We can talk a little bit more about this number in a later video. Now, that word, enclosed, is extremely important because it tells us that if there is no charge enclosed by the surface, then there's zero flux. As an example, let's say you have a hollow cube, and outside of this cube you place a positive electric charge. the net flux through this cube is said to be zero because there is no charge enclosed or inside of the cube. Why is it zero? Well, as you can see, all of the electric field going in through one side of the cube comes out through the other. So the net flux must be zero. So then, here's a quick review of what we have learned. 1. We have seen how Gauss's law tells us that there is such thing as positive and negative electric charges. 2. That these electric charges can interact with one another through electric fields. 3. That the flow of electric fields is called flux. And 4. That Gauss's law helps us to relate the flux through a given closed surface to the charges enclosed by that surface. Well, that's about it. Thank you for watching, and I hope you enjoyed.
Alright, epic stuff. Yeah, that's actually somewhat of an interesting explanation. I'm gonna go over Telegram. Okay, so this is this part right here, and is this a bit delayed? Okay, no, it's normal. Alright, and then this is gonna be here. Okay, so the other thing I was gonna go over this one. Okay, that's pretty interesting actually. And so permittivity, I'm gonna go over what permittivity of free space is. I'll be watching it a slightly bit faster. Gauss law of electrostatics. Yeah, so the flux is 0 if it's not no charge within that area, because again, lines go in and out. I'm gonna go over let's go permittivity of free space. What is it? Okay, let's see what this guy says here. I'm gonna start standing for the last bit.
Hi, it's Mr. Anderson, and this is AP Physics Essentials Video 19. It's on electric permittivity, which is best understood when you're looking at capacitance. And so for this video, I created a capacitor out of 3 layers. 2 layers of Reynolds wrap, which are good conductors, and then 1 layer of plastic wrap in the middle, which has a higher permittivity. And so in order to make this work and make it a little bit more portable, I rolled the whole thing up, and so it looks like that. If you look at a real capacitor, it's going to be rolled up, but it's essentially the same thing. You have conductors on either side and then something insulative in the middle. And so let's look at this video for just a second. Right now I'm hooking up my capacitor to a multimeter, and you can see that there's no electric charge on the inside. Now I'm connecting it to a couple of batteries, so I'm adding charge now to the capacitor, and now I'm going to hook it up to the multimeter.
Okay, so the capacitor is basically rolled up conductor, like just that the metal wrap, and then you put insulator in between, like the plastic, so the charge doesn't escape or something.
And you can see that the charge increased really quickly. And so I had stored charge in just this little amount of Reynolds wrap and plastic wrap. You can see it's kind of discharging now. And so what is permittivity? Well, if you have an electric field like this, matter has an ability to resist that electric field. And that resistance to an electric field is called its permittivity. And so the permittivity of free space would be the resistance offered by just a vacuum between those 2 conducting plates.
Okay, so if you go back to the equations right here, so basically this is the divergence, or that, I'm gonna go, actually, I like how it expands here. So the amount of electricity coming out of the electric field, it's gonna be hindered by this permittivity of free space, because that's blocking electric fields.
And so that's a constant value that we can compare other materials to. And so if we have other materials, their permittivity is based on their structure. So their atomic or molecular structure is going to be variable. And as we vary the permittivity, we can make a capacitor that is more or less efficient. And so let's look at a real basic capacitor, and that'll show you the elements of capacitance. This is what they look like today. So if we zoom in like this, what you have are 2 conducting plates on either side. So those are connected with wires. And then in the middle, we have a dielectric. And so that's going to be an insulator. It's something that we can resist that electric field forming in that capacitor. And so if we look at basic free space permittivity, so what we would have in the middle now is going to be just a vacuum. And so what we do is, as we hook it up to voltage, you're going to see that there's an electric field across that gap. And that's the free space permittivity, or sometimes we refer to it as the dielectric constant. And so for a vacuum, it's going to be 1. Air is going to be slightly higher than 1, but it's going to be pretty close to 1. And so what happens when we add a dielectric in the middle? When we add an insulator in the middle, well, that's going to be made of atoms, and atoms are made up of protons and electrons. And what happens is as that field moves through the dielectric, what it does is it shifts the electrons. So the electrons are actually being shifted, in this case, to the left. And that creates an opposite field, which cancels out that electric field. And so if you add a dielectric between these two conducting opposite field, which cancels out shifted protons and electrons. And what happens is as that field moves through the dielectric, what it does is it shifts the electrons. So the electrons are actually being shifted, in this case, to the left. And that creates an opposite field, which cancels out that electric field. And so,
Okay, so the actual electrons shift over to the left there. Interesting.
so if you add a dielectric between these two conducting plates, what you're doing is resisting that electric field. And what that does is build up a charge on each.
So that resists. How does it resist it exactly? Okay, I'll see if another video better explaining it. Yeah. Anyways, 29 tons. Could these laws and equations help someone somehow replicating the Hutchinson effect eventually? Yeah, definitely. One thing. So the way John, he would read stuff like Tesla papers and so on, but he would do more on the experimental side and so on. So what I'm doing right now is every other week I'm going to be focusing on the experiment, and then the every other week on the theory. So like go over this stuff, just wrap your head around it. When you understand electricity, magnetism, even something as simple as math, it will help guide you when you do the experiments, and also make sense of stuff that you saw. Like if something happens, and then basically instead of saying, hey, it's a super plasmoid, whatever, you can go look at the theory and be like, oh, actually that's a conventional mainstream setup there. So essentially what I'm saying is you have to do both. It will help you open up your mind and also get the words accurate. So a lot of free energy researchers, it's like they have the experimental side, but they don't have it anchored through the theoretical. You need a mathematician too, I believe. Yeah, definitely. But it's also like you have to, like these equations and so on. These are based on the experiments that the mainstream has done. So the mainstream has already documented like thousands of experiments and so on, and then these numbers they all get it from it. So if somebody says the speed of light changes, whatnot, well, mainstream is measuring it and so on, in their own setup. You cannot just throw away everything that they're doing, because they're doing something where they're all getting paid to do like the work. So they're spending hours and hours of their entire life on this in university, in the labs, in papers and so on. So what basically I'm trying to say is you have to grasp what they're talking about before, at the same time as when you experiment stuff. And again, I'll be gradually testing more and more experimental stuff, but at the same time, this will start making more and more sense. It's kind of like calculus right now. Like calculus is used for everything, but if you don't know calculus, well, it takes a while to grasp it. But if you don't know calculus, well, like you're just gonna be hoping that you'll just be winging it. Anyways,
field moves through them are made up of protons and electrons, and what happens is as that field moves through the dielectric, what it does is it shifts the electrons. So the electrons are actually being shifted, in this case, to the left. And that creates an opposite field, which cancels out that electric field. And so if you add a dielectric...
Okay, so this negative goes over to this side, that'll lower that potential difference.
In these two conducting plates, what you're doing is resisting that electric field. And what that does is build up a charge on either side. And that's how we're storing that energy. And so we now see that we have a dielectric constant that's going to be higher than our constant, which was 1. And so if we look at this PHET simulation, we have a capacitor here in the middle, and so we're going to...
Actually, this is pretty cool. I want to see what that video is. PHET simulation. Okay, this site is super cool.
Add a little bit of voltage to it, and you can see that charge is starting to build up on both sides of that plate. Now if we take a dielectric and slide it in the middle, well, this dielectric is just free space, and so you can see that it didn't change the capacitance. But if I start to increase the permittivity, watch what happens to the charge on the plates. So now we're at 2, and now we're at 3, and now we're at 4. You can see charge is building up on the plate. And each material, Teflon 2.1, paper 3.5, glass 4.7, is going to have a different constant. And if I pull that dielectric out, then our capacitance drops down to 0. And so did you learn that electric permittivity increases resistance in the electric field? We can use it to make a capacitor, which could be made simply out of Reynolds wrap and plastic wrap. I hope so, and I hope that was helpful.
Okay, so basically you can build up charge with that. Okay, that's pretty cool. I'm gonna go over some of the demonstrations, the software they have. This is actually amazing. This is like this is another part is why I like math, is because every single equation you can graph and visualize, and then basically prove it without needing like to show people, hey, this number equals that. No, like you can literally visualize it. So we're gonna go over Gauss's law. This capacitance right here. You can see. Run here. Let's see if this works. Please work. Let's go. PHE. How this is Colorado University. 4.3 million. Okay, so we got this. Main is starting. Jar is loaded. And I'm gonna go over the other one. Electric field simulator. I think we had another one. It should be also PHET. Holy, what is going on here? Okay, there it is. Okay, so here is a battery, and then you add 2 plates. Basically, you could store charge in there, and you could do a lot of stuff. So what you could do with John Hutchison, he does something like this. So the idea is you can like build up a huge amount of charge and discharge it all rapidly. So you can imagine connect it to something and see what happens. You could try to blow something up by doing that. I'm gonna just do a test. How do I start? Okay, now what? Electric field lines. Meters, capacitance, plate, stored energy, voltmeter. Okay, I can put the voltmeter anywhere I want. Okay, oh, this is actually amazing. I'm gonna send a link to this. Absolutely fascinating setup here. Okay, so I'm gonna go right here. All right. Okay, charges and fields. So you go back to that divergence things, and then we'll get into the magnetism setup soon. That's actually I might do that for another one. Bolt charge. Okay. So this side's cool. So again, this is the divergence curl. So if you have a charge, it basically means it's electricity going everywhere out there, direction only. And if you add another, and then basically if you have 2 charges, it should be stronger. You see how it's got stronger? Then we'll go to values. Is there values? No, voltage. No, that's voltage. Okay, doubles. I'm gonna remove this direction only. No. This is the electric field, and then the grid. No grid. And then you can see the measurement. The voltage is there. So see the voltage, and then basically saying if you have higher charge, you're gonna have bigger electric field. That's pretty cool. Okay, and then okay, so now what I'll do is I'll reset this. Go back to this setup here. See how this works. Okay, so this goes there. This plate charge. Okay, dielectric. Okay, so now so here's dielectric. So initially you put the dielectric. That's free space material. So right now is this free space, and then you can measure the capacitance. Okay, so this is offset. How much is in there? Okay, so now the capacitance is there. So what does this mean? Plate. What happens to the plate charge? Well, is the current? Okay, this was off the whole time. Okay, now it's on. Okay, so now if you have it positive, yeah, we'll put it on. Plate charge on the top. Capacitance 0. Okay, notice it's 1.33 times 10 to the power negative 13 coulombs. So it's super high. If I put this here, it's even higher. So it's already super high. I'm going to lower this. Okay, I'll put it like this. Okay. Plate charge is at 0. Let's go over here. Let's put it, not max, put it right here. Okay, so notice how much charge gets put. So if you have, here's free space. I made another live. Okay, interesting. So you made another live. Okay. Oh, this is the current changing. So you can change it back and forth. But this is pretty cool. So now change of material, Teflon. Look how much. So free space is that much. Paper. Oh no, this is just a custom. Oh no, this is the normal one. Normal one's here, 1. Okay, so this is free space. And then if you increase it, you get a huge charge there. So you can build up a bunch of charge here by having 2 plates, and then that's it. You just have 2 plates, and this will build up infinite charge. But if you put paper in between, let's go put glass, actually. Glass has very high resistance. Okay, so that means the charge is going to be built up on there. So what this basically means is, if you connect the wires, the current just goes through. If you separate them, the charge builds up. But then now you can build up by adding insulators, just dielectric material in between. You can change what it is. By default, is 1. Yeah, the default relative 1 is just the permitted free space, and then you increase paper there. Okay, that's pretty cool. Oh, this site's and now you can do multiple capacitors. How do you do multiple capacitance? Oh, you could shrink it in there. And these, oh, 2 in series. Okay, you can do a whole bunch of stuff here. Holy, this is pretty cool. 2 in this. 3 in parallel. Okay, so we could do, and then we can see what happens here. Dielectric. Okay, now go back to multiple. Total capacitance, electric field lines. Okay, where's, does this one have electric field lines? Okay, there's electric field lines going in. So basically, notice how much it goes in. It doesn't change, actually. It's just a drawing. Show excess charges. What in the world's going on here? Okay, that's excess. Okay, show excess only. This is the default, is just +1, and excess, it goes like that. Voltmeter. Let's see what happens if I can connect here to here. I should -0.1 volts. That's how much it goes through. Yeah, it's basically how much goes through and includes the circuit. Okay, this is actually amazing. Okay, so I at least know what a capacitor is now. Alright, so we are, yeah, that's pretty amazing. You guys can test it out yourselves. All the links will be in the, in Telegram and this setup here. I think I put it there. Yeah, there, I guess I did put it. Okay, so, and now the charge set up there. Alright, I'm pretty much, understand that there. Okay, primitive free space. What is, yeah, charge density, just how much charge is in there. And again, the question is what in the world is charge. So we have that. I'm going to go over now quickly. What is the thing I was going to go over? Okay, this is going to be the next one here. I'm going to do, okay, I'll do the same thing. So we have this one. I'm going to archive this. I think I did archive it. Let's check if I did. Peaked at MES. All right. Okay, so we have, yeah, I have the grok one. I'll do another one. Is right here. I'm gonna go new chat. For magnetism. So now the key part here. So, and this second law of this Maxwell's, in Maxwell's law, the second one, divergence of magnetic field is 0. This essentially means it's saying that there's no, that there should be no magnetic monopoles. So you can't have a charge, like you can't have a magnetic north like this. You always have it coupled. So that means that divergence is always 0. So at any point you take, you're going to have lines going in, magnetic field lines going in, and then others going out at the same time. So the flux is always 0. So that's essentially what it is. Yeah, so the derivative in and out everywhere is always going to be 0. So check your stream notes. I mean, not live. Okay, what stream notes are we looking at? This right here? What in the world are you talking about? Stream notes? Where did you post something? My stream notes. Okay, anyways, let me know what stream notes. What stream notes? Tell me or talking to Tammy? Tammy made another live. Oh, you made it to this one, yeah. But where's the stream? What stream notes? I don't know what's this guy talking about. Okay, so I'm gonna go over to Grox here. All right, so Gauss law for magnetism is one of Maxwell's 4 fundamental equations of electromagnetism that expresses the experimental fact that magnetic monopoles do not exist. Unlike electric charges, magnetic field lines always form closed loops. They never begin or end. And the monopoles things, Bob Greener always talks about yeah, always talks about the what's it called? Yeah, he also talks about magnetic monopoles and so on, but it's like he's just saying words. I'm like, yeah, there could be, but again, he's the absolute worst guy for the stuff. Actually, I have some more. I I wasn't gonna share this, but I'll see what happens here. Before we get to the magnetism ones, I just want to know what your thoughts are on these. So, this is so good. Okay, so yeah, I sent this one to let's see, right here. Okay, okay, so that's what I'm gonna click. Okay, toroidal bulb. Okay, we'll play something here, but first I want to get to the Bob, the other one. Okay, this one here. So this guy here, I'm pretty sure is his burner account. This guy Greenman. I blocked him because he keeps like hassling me with the MH70 and Bob nonsense. So I blocked him, but his name is Greenman. And if you go to his posts, he says 9/11 was done with the same technology that underpins cold fusion, and then all he does is include Bob Greener and so on, and he also includes this Matsumoto guy. Okay, someone's up with that Matsumoto guy. Anyways, and he just has clips of Bob Greener, and then now he's going after Hal Puthoff or something. But Hal Puthoff is obviously a spook. He sees toroidal and fractals and everything, as you said, even in cartoons. Yeah, but I'm just trying to say this guy Greenman. And if you search up Greener, if you go right here, search up Bob right here. So again, and then now he says 9/11 represents stronger proof for 0-point energy related than MH70s. And now he's going after, he's like, Dr. Judy Wood is right, Bob Greener is right. Okay, oh, this is a pretty epic thumbnail there. And this guy went after me. If we accept this this is technological possibility with the most incredible future ahead of us, Bob Greener on the MH70 cartoons. Let's see what he says here.
Look at that. I mean, it's just how beautiful it is. As I'm stepping through this, it's just a wonder to see.
And that's a fake frame. I made a whole video on that. No, the frame was a duplicate frame.
This technology at work. There we go.
Much of its words in factual, but they're in a different order, and so on. And some of them are horribly wrong. Like Tom McCulloch's one is deliberate lying.
And this is exactly what's orbiting around here. Look at that. I mean, it's just how beautiful.
it's just a random blob.
Totally beautiful. Sorry to the families again that suffered their losses.
Okay, anyway, yeah. So that was but he always has Bob everywhere. And now notice the combination. It's always the Bob and then Dr. Judy Wood. It's like no. You did not put this spook in there. Notice always the constant connecting Bob and then John Hudson and so on. So again, why is that guy there? Okay, it's unbelievable. All right, but anyways, so that's pretty funny. But now here's one that's absolutely the stupidest thing. One of the stupidest things I've ever heard in my life. Germany won Second World War. We might have unlimited free energy and anti-gravity on its planet in regular use for at least 50 years. This guy here is the face of Martin Fleischmann Memorial Project. Please just stop this.
That had the shocking reality that had Germany won the Second World War, we might have had unlimited free energy and anti-gravity on this planet in regular use for at least 50 years.
Okay, and also
Germany won the second.
Also, his live stream, it's so close to his face. Like he zooms in so big. It's like, what? How do you do this? I put my face tiny because I'm like, I don't want to make it too awkward for everybody involved. But yeah. So, anyways. So now we're gonna play one of the stupidest things I've ever seen in my life. So he's saying if Hitler won, we would have free energy and gravity. That's one of the. How does he have an audience after that? How does he have an audience? How? Like why? Anyways, let's play this. And this guy's got white hair. Interesting. What in the world's going on here? Is he talking to an Anunnaki?
Where you've gone across a nylon floor, or you're wearing certain clothes, it's dry, and then you have a spark coming out of your finger, and you go, "Oh, someone's got shot." Or you do it on a doorknob or some grounded object.
Yeah. What's
happening there is you have all charge on your body, and there's something that's flowing out of your body, and this forms the toroidal structure, and it produces a microball lightning coming out of your finger. But the flux is always coming out of your finger, and you can see this in Kirlian photography. So you put your hand down on a radiographic plate, and you get your body charged, and you see these things coming out of the points. Why? Because you get a space charge increase at a point, and the points on your body that are most pointy for most people are your fingers, right? Now, when you have this coming out of your body, and you go into this position, I mean, specifically this position, right? When you are meditating, you have these structures coming out, producing an ether vortex, and you have these structures coming out, producing an anti-ether vortex. That produces the magnetic loop here, or the toroidal moment through the center. And that is able to interact with the dark matter that is flowing into the Earth, which is a model of gravity. And it's going into the Earth. Why?
Okay, anyways, did you hear what I just said? So micro ball lightning comes in here when you do a yoga pose, and it circles around you, and so on. Okay, Matt is a good guy so far, but he's probably just in a position to be initiated. Okay, I'm talking about this guy here. Okay, but he's got white hair and so on. Yeah, but this guy here is like talking about yoga pose nonsense. I'll go to 14. All right. Okay, I'll just say yoga pose equals micro ball lightning. I'll do a post about this, but it's just so bad. Lightning vortex, yeah, plus toroidal vortex. Dark matter anti-gravity. Oh my goodness, man, this is comma, okay. Like if you all believe this nonsense. Okay, this is what you should do when somebody says that. Anyways, like I don't have too big of an issue with them doing all this nonsense, but again, when you're the trying to be the face of a Hutchison, Martin Fleischmann, and 9/11, yeah, just please stop. Just get away from everything. And also go back to the other thing here. This is a pretty good one here. Okay, Greenman burner account plus Hitler winning equals free energy. Like just like y'all gotta stop. Just like please stop, guys. I shouldn't be the one having to do this. Like you guys should be the one. Hey, look at this guy, absolute clown show. Instead of saying, hey, look, this guy's talking about vortex and free energy and so on. No, he said, but this guy's an absolute clown show. Here's some good material to expose him. Yeah, he says, well, all these things. It's like it's so stupid. Like, and I'm out here going like video after video on like Gauss law, like just to wrap my head around when the world's going on here. And then we're taking questions live, and you're asking what's the application on this. And I think I was talking about like vortex anti-gravity, like yoga pose, free energy, toroidal vortex. Like what in the world? And he says he creates these micro ball lightnings in a lab every day. I'm like, no, you don't. Like, show me something. Yeah, it's like he talks as if he has done anything remotely like John Hutchison. Like John Hutchison is literally levitating a 80-pound mail ball or a bowling ball. So it's like, what do you guys want? It's so basically, if you talk big, you gotta show something. All right. Anyways, so that's the charge. Let's go back to the charge setup here. So Gauss' law for magnetism now, and that's the Gauss' second law. So this one here, so that's what it was the whole time. Okay, so you need to integral there at all times. So I definitely need to do a video on that. So I'm gonna go back to Maxwell's equation. So now this one here, this basically the derivative and sum it up is equal to 0. The derivative is just rate of change of the field going in when you're taking every component, and equals 0. So the divergence is 0. So the flux is 0, and that's Gauss' law for magnetism. We'll open this up. Yes, but he does. It seems genuine. Yeah, he does to a point. I think he's definitely delusional. But the atomic clocks one, I think I caught him in a very sensitive spot. He just reads books a lot. You know, I know he reads stuff, but he pronounces words and so on. But like atomic clocks, he's a straight up lying. There's nothing about it. And to illustrate this as well, so when I was doing the video for these atomic clocks, again, Global Conscious Project has nothing to do with atomic clocks. Okay, nothing to do with atomic clocks. All right, and atomic clocks don't have anything to do with decay, radioactive decay. So it's like, what is he talking about? It's like me saying the polar bears they change their flight path. First of all, they don't have flight paths, and second of all, polar bears can't fly. Okay, so going back here, if you see this higher side chat one, I think this 1 minute video was done on purpose by higher side and him as promotion for the stream, but it was never in the stream. So this video,
If your theory for 9/11
and you notice he does a finger thing.
cannot explain the magnetometers,
Notice how he combines magnetometers with atomic clocks nonsense.
cannot explain the Global Consciousness Project finding, and it cannot explain the iron-rich crenellated spheres, you are absolutely wrong, totally. The Global Consciousness
And notice there's a theory and all that.
Project found that atomic clocks all over the
This is a lie. Like, why? This is straight up lies.
world changed their decay rate during
Decay rate, it's like he's literally just lying. Everything's a lie.
9/11. Why? Because the technology
And this guy's pretending to be. This guy's pretending to understand, to have a clue what he's saying. And I think he's purposely pretending. I think this guy are in on this nonsense.
that was used to create it was intensely magnetic in a sense, but also it was sucking relic neutrinos out
So, relic neutrinos. No, this is the stupidest thing.
of the environment. And so they were not able to cause the atomic clocks to be able to decay at their normal rate. It was nothing to do with the attention of humans on the event, as they claimed.
Yeah, and notice the guy pretending to be pretending to understand
On the event, as they claimed, it was caused because there was a big thing sucking in these relic neutrinos, ready to create the party, what I call the party trick on the event. They did a huge party trick, and then they replicated it just under an hour.
Wow, that makes so much sense because the
If you think that makes sense,
consciousness thing,
Yeah.
that little blip on the results has always been interesting, but it's never been explained to me until just now.
okay. So now he says, watch the full interview, right? It's not in there. It's not in there. The full interview is not in there. If you go to the full interview, higher side, that's my take on these guys. Yeah, but if you go right here, and then let's go to Bob. Greener, let's go to Greener. How many? Greener. Also, this weird video of him eating like a lizard or something. So if you go right here, and if you go to atomic, show transcript, there is atomic clocks. There is no atomic clocks. You can't. There's no clocks anywhere. Consciousness. Let's go. Global consciousness. There's no global consciousness. It's not even in this. It's not in there. 1 hour 48. I couldn't find it on the website. No, it's nowhere. If he's genuine and saying wrong stuff, that makes him stupid. Then no, he's lying straight up. And again, he's got Freemason. His grandfather made a Freemason lodge. Yeah, but this one, it's not in the stream. So like, and this guy clearly has no idea what Bob is talking about, because Bob doesn't even know what he's talking about. And then, but also this guy, they had Judy Wood on like years ago, but without a video. 10 years ago, they had Dr. Judy Wood on, and they had Andrew Johnson 5 months ago. So it's like this is the thing, is like you cannot, you have to run away from these people. And I think they have Ashton as well. Ashton Forbes, or they got Ashton Forbes on here. Ashton Forbes, like what do y'all want from me? Like absolute clown shows. Anyways, that's clown shows for me. Okay, let's go back to the magnetism part. It's only this here. Okay, there's only little clips there. Clips, MH70 on censorship and so on. So if you guys can find, the nonsense, the full one, please somebody find the full one. I can't find the full one. And again, and also notice what he says multiple times here.
I didn't find the written source for this.
He literally says, I didn't find the written source for this, and then would tell it. He said this during the interview with Andrew Johnson.
The global consciousness
yeah, but then so I made it repeating nonstop. But listen what he says.
I didn't find the written source for this.
And he didn't find a written source for this. But also, if atomic clocks change, they're one of the most sensitively measured things in the history of the world. If they changed, everything would know. You would know just by your GPS. Be like, hey, how come my GPS is off by like 20 meters? The entire world would be on the news. You wouldn't be needing to do this. It's like Hurricane Aaron. It's like, imagine Dr. Judy Wood was talking about Hurricane Aaron, but it was never there. It's like wait, what's going on here? Anyways, that's enough for me clowning him. But I'll be clowning more on him later. It's just so ridiculous. Anyways, so here's the charge. So essentially magnetic field lines here. I'm gonna go back here. So Gauss law for magnetism is right here, and In physics, Gauss law of magnetism is one of the four Maxwell's equations that underlie classical electrodynamics. It states that the magnetic field has divergence equal to 0. In other words, it is a solenoid vector, so it's always a circular. It's always circular vector. It always comes back to its sort. It's always in a circle. A vector field, it is equivalent to the statement that magnetic monopoles do not exist. Rather than magnetic quote charges, the basic entity for magnetism is the magnetic dipole. So it's always a dipole. If monopoles were ever found, the law would have to be modified as elaborated below, where some theorize on monopoles and so on. Gauss law for magnetism can be written in two forms: a differential form and an integral form. These forms are equivalent to the divergence theorem. The name Gauss law for magnetism is not universally used. Okay. Gauss law for magnetism can be written to these forms are equivalent due to the law is called absence of free magnetic poles. That's what the law is called. That chart could be used on elements and compounds. What chart? Yeah, maybe. It is also referred to as a transferability requirement because for plane waves it requires that polarization be transverse to the direction of propagation. Interesting. It needs to be transverse. Holy, okay, that's a polarization part. There's a lot of stuff here. I want to get one thing that I could state as fact and then build from there. But it's like there's so much info on electromagnetism. And so much media saying monopoles exist and all that, and polarization can be longitudinal and without transverse. Einstein Dino says that, but it's like yeah, but we need to account for everything they're saying, and just to see whether they're exactly wrong. This is Gibbs free energy. I heard about that Gibbs free energy. Interesting. That'll be something I maybe do for future streams. The differential form for Gauss' law of magnetism is divergence. Is this? So you have to grasp divergence. Essentially, these are the vector fields. You cannot have it at any spot. Yeah, so let's see. It's always going to be in and out like that. There's never a point that's generating them. You just have zero. You don't have any free magnetic poles. You always have a continuous field. You never actually have just a source of it. There's zero. Notice that there's no source of this magnetic field. It's just that. Okay, vector potential. Let's go field lines, equations. Okay, I'm gonna go over to here now. See the Grok one. Gauss law for magnetism. Okay, we have 12 minutes to start power throughs. Gauss law for magnetism is one of Maxwell's four fundamental equations of electromagnetism. It expresses the experimental fact that magnetic monopoles do not exist. Unlike electric charges, magnetic field lines always form closed loops. They never begin or end. Integral form. Yes, that's the thing. They never begin or end. That's the key part. This would need Fractal Woman's programs. Yeah, there's other. Okay, it's not just Fractal Woman. It's the other person who has. Okay, if you go to Fractal Woman's ones, this one I do need to get some info on it. I mean, make videos on this person. Also, maybe possibly get her on the show. So Chantel Roth is.
So today we're gonna try.
I don't know if she's using AI or not, but she's got absolute epic models for all this. Channel. I should subscribe. Yeah, okay, I'm subscribed. Okay, Red Pill and Fractal Woman. What's her name? Red Pill? Okay, her name is Red Pill. Okay, I want to see her site there, simulation. So she has other simulations, Electric Universe. Okay, so she's the one that's doing Electric Universe site. So she's the one that's got a whole lot of okay, so she's using Claude, I think AI code completion. Okay, she's using a whole lot of cool stuff here. Whoops. So I definitely need to see this. Okay, so here's the simulation. I'm gonna have to bookmark this. This is a bookmark it where in the world can I bookmark it content? I'll put this in my later thingy. I'm gonna put this in my later. And this is one of the coolest things ever. She's like a professional programmer and Scientologist researcher. Greener co-founded Intermucca, a private digital visualization firm based on Czech Republic. They use advanced 3D rendering engines to create interactive objects such as architectures. Interesting. Yeah, because he did architecture of no, he did data architecture or engineering, construction or something like that. Yeah, definitely. So he is very good at this visualization stuff. So that's why the dust sample nonsense is he literally has the super advanced model he made to go over some insignificant random dust specks that we have no idea where it's from, and who even cares? Does that explain how certain dust, and so on? So I'm gonna go here. This is one of the coolest things ever. But this person's got And again, a lot of these, according to her word, it fits exactly, like matches exactly mainstream setups there. So she takes those in, matter wave setup here. See how these all work. Pool refracting, Steinberg refraction. I want to get to the one she has for the spherical harmonics. I want to get to the other one. She has the one on Michelson-Morley experiment. Okay, so this is, I want to get to the other one. Okay, I'm going to go with Michelson-Morley. She has one on that uses time, length contraction. Morley. Michelson. Length. Just include length contraction. Like, why does she not make it super easy? Special relativity, kinematics.
So today we're gonna try.
Like, where does she put these links? My goodness, just give me the link.
So
What
today
am I clicking? What am I? Okay, Doppler effect. Okay, she has all the links here. Simulations. Wave speed depends. Refraction gradient. Where's Michelson? No, there's Michelson-Morley. Measuring motion. Length measurements. Twin paradox. Okay, see, this is the paper, I think. Okay, this is the length contraction one. So she has some pretty wild papers here. So, and you can see this setup here. The light comes back at the same time. But then if you add an ether, where's the ether moment jump? Wave speed. What the hell is going on here? How do I just make it smaller then? Okay, make it smaller. Whoops. Okay, there's the site. The site's pretty good. How do I just block this off? Let's just close this. Okay, so she's using this site there. It's ridiculous. I can't even close it. Can't even have to pay to just to close it. Like, what kind of trash is that? Yeah, I'm gonna be using Claude to try to get stuff like this hosted directly on my website instead of using these other nonsense, like centralized sites. Okay, so resultant wave speed. Where is the with length contraction? Okay, so apparently without length contraction, they go at different times. How do I make this proper? Okay, beta velocity. What in the world does this mean? Okay, there's the that's the ether wind. So here's this thing fires this way. Okay, no, yeah, so it fires and it's split. So that's a beam splitter. It splits so that you have the exact same different setup, and then they go back exactly same spot. A detector measures that. And now if you have the velocity versus the velocity of ether. So if you're moving in the ether, this would slow down. This would be not affected. And then this reaches first. So this top one reaches first. It would go to super high speed. Okay, so now this one's super slow. Okay, yeah, this is much better. Okay, so this is super slow. Pulse rate, let's go 1. Let's go on a 1. Wave speed. Okay, wave speed is faster. Okay, so now what I'm doing is, okay, now, Spectral Luminescence programs. Yeah, but this is, Chantal Roth made these ones. Chantal Roth is the one who made these ones. And she's been on Fractal Woman's channel a lot. So this is pretty cool. So now it splits up. This is actually one of the coolest. Yeah. Now notice how it goes fast here because it's not affected by ether. This is because they don't account for length contraction. But again, even then, that's a bit weird. You have to explain why does the mainstream not account for length contraction? Like, what's the reason? Why is there unless so basically the reason I say why is the reason because the reason you have to confirm, is it conspiracy or is it just they don't consider it as important? Okay, now what we'll do is with length contraction. What happens with length? So this gets smaller in this. Okay, so that gets contracted. Okay, that makes sense. There it is. That's pretty cool. Okay, there it is. This is pretty cool. Yeah, so basically, and the thing is, I tend to agree with this length contraction setup. And this is usually mainstream setup there, just accounting for length contraction. The reason is because even though this is super exaggerated, what the mainstream science is they're actually looking at, Michelson-Morley, is like super tiny difference in measurement. Like, who cares? Who cares? So length contraction could argue for that. So Chantal Roth, amazing. Michelson-Morley. How do you spell Michelson-Morley? Unbelievable. Like Michelson-Morley. Okay, Morley. a Morley experiment. Simulation with length attraction. Okay, this is amazing stuff. And I'll put the other link as well. This setup here. And I like how she put all the links everywhere. So this is, and if you listen to her talk, she's probably one of the few open-minded, like, like one of the very rigid, rigorous researchers, but is also open-minded. So it's like rigorous and open-minded. It's not easy to come by. All right, so that's that part, and then okay, so see here. It's actually amazing. Definitely I'll try to get on the stream one day. Anyways, yeah. So let's go back with 3 minutes to solve for Gauss law for magnetism. Okay, so I'm going to read this whole thing. Gauss law for magnetism is one of Maxwell's 4 fundamental equations of electromagnetism, and it expresses the experimental fact that magnetic monopoles do not exist. Unlike electric charges, magnetic field lines always form closed loops. They never begin or end. Integral form, flux through a closed surface. The flux is going to be 0. The total magnetic flux through any closed surface is exactly 0, because whenever you go out, it goes back in. And differential pointwise form, this becomes this. Partial inductor. Okay, yeah. There's a lot of interesting people, but again, whenever there's new names there, it's like you have to always be on your A game. But unless Chantel looks, these models are amazing. I need to replicate it myself. Partial differential form. Cartesian coordinates, expanded terms, let the magnetic field vector be this. Okay, so that's it. This basically, you take a partial derivative of the vector field in the x direction in terms of x and the y, and then z add them model up, and it's 0. The net source or sink of magnetic field is 0 everywhere, so there is no source for magnetic fields. This is why we can always define magnetic vector potential A such that that's a cross product setup there. And that's with the and that's where it comes, where the vector potential comes in, because of this whole fact. So something needs to be generating these, but it looks like it always exists. Like there's no it always exists. What is that? How does that statement is? Nothing creates or destroys them or something. Gauss law for magnetism. I'm gonna close this one. This is charge. Gauss law for magnetism right here. Okay, it can be written. Where's the other setup? It's basically okay. Equivalent to the same as the magnetic poles do not exist. Yeah, basically that's what all it is. Magnetic monopoles don't exist. So you can create a magnetic field, but you can't create a magnetic monopole charge or something. All right, so we have that. Go back to this grok setup quickly. This is why we can always define a magnetic vector potential A such that this taking the divergence. Okay, so key applications: transformers and inductors. Magnetic flux is conserved inside the core, closed loops, core design, flux linkage calculations, leakage, flux minimization. Electric motors, generators, magnetic field lines closed through stator, rotor, no monopoles means flux continuity, torque production, back EMF calculations, magnetic. Okay, so you use a whole lot of stuff here. Okay, yeah, it's pretty straightforward. I'm going to do one quick video on this. Gauss's law for magnetism. Yeah, we have last second. Let's explain this one here. No monopoles. See if there's a shorter one. Okay, let's play this one here.
Good morning. Flippin' physics.
Unbelievable.
Surface integral of the dot product of electric field and area dA, which equals the charge enclosed in the Gaussian surface divided by the permittivity of free space. Gauss's law for magnetism has to do with magnetic flux. Gauss's law for magnetism states that the magnetic flux through a closed surface equals the closed surface integral of the dot product of magnetic field and area dA, which equals, well, that's what we're going to figure. Let's put an illustration of a magnetic field which surrounds a dipole magnet. Bo, remind me what the fact that magnetic monopoles have never been found in nature means for magnetic fields.
Sure. Because magnetic poles always come in pairs, magnetic field lines are always closed loops. And that means that inside the magnet,
Holy, okay, this guy's absolute. I cannot listen to this. Just give me the answers. I just want the answers. I don't want any extra nonsense. Okay, Gauss law for magnetism. Where's the monopoles law? So here's a shorter one.
In the previous concept, you studied about magnetism and matter introduction. In this concept, you study about Gauss law for magnetism. We can derive Gauss law for electric field. Phi E bar dot ds bar is equal to 1 by E naught Q total inside, equation 1, where phi E bar dot ds bar is the electric flux. Law for magnetism as phi B bar dot ds bar is equal to mu naught M inside, equation R.
What in the world did I just? It's like okay, I just want someone that can explain it in 3 seconds. Okay, super simple Gauss's law for magnetism.
The next concept is what we call Gauss's law in magnetism, and the fancy way of saying this is right here. The integral of B dotted on dA through any closed surface. That's what that means right there. It's the same symbol as a closed loop, but in this case it means a closed surface, like a sphere, something that's got an inside and outside, or a box. Anything that's got an inside and an outside is a closed surface. Now the magnetic flux through any closed surface is got to be 0. All that means is this. Here's a magnet right here. And here is a surface, a Gaussian surface surrounding this magnet. Any magnetic field lines that leave out here, well, they've got to just come back in that surface later. And that's all that means, is that every line that leaves any closed surface has got to come back into the closed surface. It just means that all magnetic field lines form complete loops. That's all that that means. You can't have any magnetic field lines that leave a surface, go out of it, and don't come back in. Now, there is a theoretical possibility that magnetic monopoles do exist, and that is the only way you could get a non-zero flux. You'll notice that no matter where you pick your surface, like if I pick it right here, there's a closed surface, any magnetic field lines that enter also have to leave. So the net flux is 0. If there were magnetic monopoles, in other words, something that is just a north end of a magnet, like a you could call it a positive magnetic charge, or you could just relabel this as just a north end only of a magnet. If we had that, then we would have non-zero flux. But so far, none have been discovered. Now, if you discover a magnetic monopole, you have just won the Nobel Prize. So good luck doing that. It would make things make a whole lot more sense if there were magnetic monopoles, because then Maxwell's equations would be a whole lot more uniform and symmetrical. But so far, we haven't found any. Now, it may just be that in our part of the universe, there aren't any, or they're very rare and we haven't found any. But until then, we do have this law, which is called Gauss's law in magnetism, because it looks just like Gauss's law, except instead of an E there, there's a B there. Bottom line for Gauss's law in magnetism, it means that all magnetic field lines form complete loops. Whatever magnetic field lines leave a closed surface, like a box, they have to come back in some other time. That's all there is to that. Easiest of Maxwell's equations.
All right, okay, that guy was pretty good. That was a pretty good tutorial there. But also, I just realized, so I have a video I made based on Fractal Woman's hypothesis. So if I go to MES physics, okay, I'm gonna go MES links. So we go to physics. Okay, physics. Okay, MES physics, MES science physics playlist. If I go here, so if I go here, and so magnetic field resembles electric field of two bound charges. So this is a pretty good one. I'm gonna play this last video. Make it a normal speed. An electric current through a metal wire produces a magnetic field just like a permanent magnet. The magnetic field is the shape formed by iron filings in the presence of a magnet. An electric field represents the force between electric charges. Like charges repel, opposite charges attract. The magnetic field resembles the electric field of two separated charges. Electric field simulator. The electric field matches the simulator. The magnetic field resembles the electric field of two bound charges. Is a bar magnet just a collection of many bound and aligned charges? All right, there it is. That's it. All right, so we just solved it. So electric field, this is from Fractalman, the idea. That's pretty fascinating. An electric current through a metal wire produced. All right, so magnetic monopoles are just just electric charges. That's it. And then when you have them bound, you have a magnetic field. So that's all it is. And you can see that right here. Put them together, you have magnetic field. If you stack enough, put another plus. Put them all bound. And then minus. And again, and when we talk about exotic vacuum objects and so on, I think it's just charge clusters. When you cluster a bunch of charges together somehow, you get magic stuff. The question is what's charging it somehow. Anyways, that's pretty cool stuff. And I will post this, and that's it. Yeah. Whoops. Okay, so pasted that. This goes right here. Alrighty. Magnetic field equals bound electric charges. Alrighty. And then also I'll put this thingy so you guys can play around with this. And yeah, let me know how that goes. If it all works. And one more thing I'm gonna do before I exit. Yeah, so yeah, the stream is pretty much done, but I'm gonna go over to my physics one. I'm gonna start putting these in here. I'm gonna go and add plus. Oh, the stupidest thing is like a bug in a $1 trillion company. There's a bug. Can't even add videos directly. You cannot add. I'm already signed in. You can't even add videos. It's so utterly stupid. Okay. I'm gonna go right here. I have to do this the hard way. I'm gonna go add this. Where's the videos I'm gonna add? I was gonna add this one here. Save to playlist physics. Should add this to the physics one. What has just happened? Just add it to the physics. Save to playlist. Physics. Okay, MES physics. There it is. Save to the physics one. Okay, physics. There it is. And these as well. I'm gonna add all these. Save to physics. Save to physics, and so you'll know where it's gonna go. I'll add these as well. Save to play this physics one. I should put those all in there. And now if we go to the physics, see how this looks like. Yeah, and then just add these at the bottom and so on. That's pretty cool stuff. Alrighty, yeah. So actually, it's in order, so let's leave it like that. Alright, anyways, that's all for today, guys. Thanks for joining. I'm gonna close some stuff, close everything. Yeah, definitely check out these videos by Chantal Roth, and I think I should archive this unless I haven't already. It's yeah, it's gonna go archive, and archive on blockchain, on the Hive blockchain. There it is. Alrighty, we are done. Alright, thanks for watching, guys. Yeah, thanks for watching. Yeah, great, Tim, and thanks for watching, and have a good day. And have a great day. And it's also Canada Day, guys. Great day. And it's also Canada Day. And it's also my half of her ex birthday, because my dad, my mom, my aunt, my uncle, like half my older cousins, they all picked their birthday July 1st Canada Day, because there was an issue with the census, so like nobody had paperwork for their birthdays. Anyone that was born before 1970s or something. So it's everyone's birthday right now. All right, thanks for watching. Yeah, also good talking to you, Tim, about the the fractal toroidal moment guy. Anyways, guys, adios. Have a good one, and ending stream in 3, 2, 1, end stream. All right, ending, and then we'll go finish.